Looking up at the night sky, we don't just see distance, we see time. Each point of starlight, each faint glow, and every luminous swirl is a message from the past, traveling vast reaches of emptiness before reaching our eyes. Every photon that strikes the sensors of our telescopes or the retinas of our eyes carries the memory of a journey begun long ago, perhaps even before Earth itself formed. Some of these cosmic messengers have been traveling for 13.8 billion years, bearing silent witness to the birth and evolution of the universe. Light is humanity's most powerful tool for exploring the cosmos. It reveals the celestial wonders twinkling overhead and offers keys to unlocking the mysteries of creation itself. In a very real sense, every telescope functions like a time machine, granting us the power to peer not into the future, but into the deep past. Today, we trace the story of how light connects us with cosmic history, showing us the universe as it was, and helping us understand how it came to be. Light, at its most fundamental level, is both a particle and a wave, a phenomenon woven into the very fabric of space and time. Its speed, though staggeringly fast by terrestrial standards, is ultimately finite. In the vacuum of space, light travels at 299,792 kilometers per second, almost 300,000 kilometers in just a single second. This cosmic speed limit has profound consequences. It means that the farther away an object is, the longer its light takes to reach us, and so when we gaze upon the universe, we never see what is. We see what was. Consider the sun. Its light, so familiar and essential, takes about 8 minutes to journey the 150 million kilometers to Earth. We don't see the sun as it is, but as it was 8 minutes ago. Our nearest galactic neighbor, the Andromeda Galaxy, lies 2.5 million light-years away. When we see its majestic spiral arms gracing the night sky, we're actually looking at light that began its journey before Homo sapiens even existed. This is the essence of cosmic time travel. Each star, nebula, or galaxy offers us a unique window into the universe's past. The farther we look, the deeper into history we peer. High-powered telescopes like Hubble and the James Webb Space Telescope transform our understanding of the cosmos precisely because they collect faint ancient light from impossibly distant objects. With every new observation, we extend the boundaries of known history, reaching ever closer to the very beginning of time. But the universe has another lesson to teach us. Even our best telescopes can only reach so far. The observable universe, the grand bubble of everything from which light has had time to reach us, extends to a staggering 46.5 billion light-years in every direction. This limit is determined not by the inherent size of the universe, but by the interplay of two factors: the finite age of the cosmos itself, and the finite speed at which light travels. The universe is roughly 13.8 billion years old, but due to the relentless expansion of space, the farthest regions from which light can reach us are much more distant than 13.8 billion light-years. As the universe stretches, it carries galaxies with it, causing their light to take even longer to arrive, and to be stretched in wavelength, redshifted, along the way. Thus, our visible universe is an expanding bubble with us at its center, not because we or our planet is special, but because from any location in space, light can only travel so far since the dawn of time. The deeper we look, the closer we get to the universe's origin. But there is a horizon beyond which lies eternal darkness. We simply cannot see further, for those places are too distant for their light to have ever reached us. Yet, within this observable bubble, light offers us the most extraordinary of cosmic postcards, the faint, omnipresent glow known as the cosmic microwave background, or CMB. The discovery of the CMB is among the most profound in the history of science, for it is nothing less than the oldest light we can observe, an echo from the very beginning. In 1965, two scientists, Arno Penzias and Robert Wilson, stumbled upon a strange, persistent microwave noise coming from every part of the sky. This feeble signal turned out to be the afterglow of the Big Bang, a relic from a time when the universe was just 380,000 years old. To put this in perspective, if the age of the universe were compressed into a single year, the CMB would be like a photograph taken at 23 hours, 59 minutes, and 59 seconds of December 31st. Before this moment, the universe was a seething, opaque ocean of plasma, too hot for atoms to form, and too dense for light to travel freely. Then, as the cosmos expanded and cooled, Electrons and protons combine to form the first simple atoms. Suddenly, light could roam unhindered, free to stream across the universe. That light is what we see, billions of years on, as the CMB. The CMB is extraordinarily uniform, yet it contains tiny fluctuations, imperceptible temperature differences, less than 1 part in 100,000. It's these ripples that are perhaps the most important feature of all. They are cosmic fingerprints, encoding the subtle seeds of density that would, over eons, coalesce into galaxies, clusters, and vast cosmic structures. By carefully studying the patterns and details of the CMB, cosmologists have pieced together a story of cosmic evolution, mapping the composition, geometry, and fate of the universe. But even the CMB is just one chapter in a much larger tale. Modern telescopes, designed with unprecedented sensitivity and precision, have become our ultimate time machines. The venerable Hubble Space Telescope, for example, has peered deep into cosmic history, capturing images of galaxies forged less than 1 billion years after the Big Bang. Even more recently, the James Webb Space Telescope has pushed our gaze further still, using its powerful infrared eyes to see through cosmic dust and look back to a time when the first stars and galaxies were being born. Planck, a mission dedicated to mapping the CMB, has given us the most detailed portrait yet of the infant universe, all thanks to faint microwaves only a few degrees above absolute zero. Hubble's iconic deep-field images, painstakingly gathered over weeks of exposure, have revealed thousands of hidden galaxies in what appeared at first glance to be an empty patch of sky. And with James Webb, astronomers are witnessing the cosmic dawn, watching as the first stars ignite, galaxies assemble, and black holes stir to life. Because the earliest galaxies are so distant, their light takes billions of years to reach us. Not only that, but the light originally emitted in the visible or even ultraviolet part of the spectrum is stretched by the expanding universe, shifting into the infrared. That's why the James Webb Space Telescope, with its giant mirror and cooled infrared sensors, can do what no telescope before could hope to achieve: pierce the fog of the early universe and deliver images of cosmic structures forming mere hundreds of millions of years after the Big Bang. But astronomers have an additional, miraculous gift at their disposal: the cosmos itself, acting as a magnifying glass. This is the phenomenon known as gravitational lensing, predicted by Einstein's general theory of relativity. When light journeys near a massive object, a galaxy for instance, or an entire cluster, the fabric of space-time is warped and curved. Light, which always travels along the shortest possible path, is thus bent and redirected, much like scenery seen through the base of a wineglass. Gravitational lensing can produce a range of stunning effects: multiple images of the same background galaxy, elongated arcs of light, or even perfect rings known as Einstein rings. But beyond distortion, lensing dramatically magnifies the light of background sources, allowing us to see galaxies that would otherwise be too faint or distant to detect. Nature, in its grand design, has constructed a network of cosmic telescopes, scattered throughout the universe, enabling us to look farther and fainter than our instruments alone could ever dream of achieving. With these natural and artificial lenses, astronomers have caught glimpses of galaxies and stars from an epoch when the universe was a fraction of its current age. They have identified some of the most distant known objects, watched the gradual assembly of galactic clusters, and even detected individual stars magnified by tremendous factors. But cosmic time travel doesn't end with the slow unfolding of galaxies or the settling of cosmic structures. Light offers us snapshots not only of gradual evolutions, but of cataclysmic events, moments of violence and grandeur, frozen in time and delivered across the ages. Supernovae, the explosive deaths of massive stars, shine so brightly they can outshine entire galaxies for days or weeks. These explosions are cosmic lighthouses, their light arriving at Earth sometimes billions of years late. Gamma-ray bursts, among the most energetic events known, unleash torrents of radiation in incredible fleeting bursts. Though these explosions are over in seconds or minutes, their light can continue its journey unimpeded, eventually providing valuable clues about the early universe. Equally remarkable are the quasars, blazing beacons powered by supermassive black holes at the centers of galaxies. Quasar flares, rising and falling over years or centuries, can be seen from across the observable universe. Each of these events provides a frame in the ongoing cosmic movie, a sequence of images allowing us to reconstruct cosmic history, moment by moment, explosion by explosion. When we observe them, we watch events that transpired eons ago, Stars that have long since faded or galaxies that may have transformed entirely remain preserved, just as they were, until their light completes its cosmological journey. Together, supernovae, gamma-ray bursts, and quasar flares let us witness the life cycles of stars and the extreme physics at play in the universe. Through them, we measure the expansion of space, uncover the birth and death of elements, and probe the mysteries of gravity and matter at the greatest extremes. And thanks to the inexorable march of light, these stories will continue to arrive, silent, beautiful, and ancient, so long as the universe exists to illuminate them. And so, as we tilt our telescopes skyward, we participate in an unbroken chain of discovery that stretches from the dawn of humankind back to the birth of time itself. To look out is to look back. We are surrounded by ancient light, whispering stories across the void. Stories of creation, destruction, and the profound interconnectedness of all things. In every twinkling point of starlight, in every distant glow, we are confronted by the cosmic time machine, one that operates not on gears or circuits, but on photons traveling through time. With the help of scientific curiosity and ingenuity, we decode the messages written in ethereal light, building a picture of the universe that grows ever more detailed and awe-inspiring with each new discovery. At the heart of this quest lies a spark, a yearning to understand not only what the universe is, but how it came to be, and how its past continues to shape our present and future. Each discovery leads us to new questions. What was the universe like in its infancy, when time and space first emerged from the primordial fireball of the Big Bang? How did the earliest galaxies come together, and what role did dark matter and energy play in their formation? How did stars, planets, and life itself arise from the swirling chaos? These questions drive us to build ever more powerful instruments, to reach further and further back, to gather the faintest and most ancient light. We stare into the darkness of intergalactic space, coaxing out the secrets held within, and in so doing, transform our understanding of reality itself. The oldest light teaches us humility and wonder, reminding us that our story is part of a much greater cosmic narrative. Imagine, just for a moment, the journey of a photon present in the CMB. Born in a wild epoch when the universe was less than 1,000,000 years old, it spends most of its existence traversing a universe that is nearly empty. Eons slip past as galaxies coalesce, stars flare and die, and solar systems form within swirling disks of dust. Planets take shape, some nurturing life, others destined for solitude and silence. Finally, after an odyssey of 13.8 billion years, this ancient photon bumps into an instrument built by an intelligent species on a rocky planet orbiting a rather unremarkable star. That fleeting moment, the detection of a single photon, completes a story that began at the very dawn of everything. As you look up at the stars tonight, remember that you are witnessing not just celestial beauty, but cosmic time travel in action. Each glimmering star is a window into the past. Some are so distant that their light began its journey before Earth even existed. The starlight raining down upon us tonight is a gentle whisper from epochs long forgotten, a message encoded in the language of light. When we ponder the scale of time and distance revealed by the universe, our own human lifespans seem fleeting, our stories mere flickers on the grand tapestry of existence. Yet, as a species, we possess the unique ability to piece together these ancient clues, to uncover the cosmic history that connects us to all that came before. The universe, it seems, has left us a trail of breadcrumbs, lights scattered across time, waiting to be gathered, studied, and understood. Physics and astronomy, decades and centuries in the making, come together as we map this light, extract its stories, and learn how the cosmos that surrounds us came to be. What science has revealed is both humbling and exhilarating, a universe that is 13.8 billion years old, governed by laws we have deciphered, and awash with mysteries yet unsolved. As new telescopes come online and new discoveries are made, more ancient light will reach us, allowing us to probe deeper into the fabric of time. Perhaps one day soon, we will gaze even closer to the cosmic dawn, unlocking the secrets of the universe's first stars and galaxies. Perhaps we will witness the echoes of forces even more mysterious, like dark matter and dark energy, which continue to shape the universe's fate. But our journey does not end here. As we learn to read the messages encoded in ancient light, we inch ever closer to understanding not only our origins, but our ultimate destiny. The cosmos, after all, is not static. Its fate, like its past, will one day be written in starlight, or in endless darkness. In the coming days, we will turn our attention from the past to the future, from the birth of the universe to its possible endings. For as surely as the universe began, so too must it end. Yet tonight, as the glow of early galaxies fades into the deep background of the universe, as photons ancient beyond imagining bathe our world in their gentle radiance, we are left with a profound sense of amazement and gratitude. To be alive, to witness the unfolding of the cosmos, to listen to the stories carried by the oldest light. This is the birthright and privilege of sentient beings. As the stars shine down, their messages inscribed on beams of light, we find ourselves connected through time to the origin of all things. Every observation, every discovery, every photon caught by a telescope tells us more about our grand cosmic home. Cosmic time machines allow us to do the impossible, to see the past, to witness the universe's infancy, to walk among the stars as they once were. Tomorrow, we will turn our gaze the other way, pondering not just the memory inscribed in ancient light, but the destiny of the cosmos itself. For every story has an ending, and the universe is no exception. Join us as we journey to the end of time, seeking to uncover how the universe might ultimately die, and what that may mean for us and for all that exists. Until then, remember that every night sky is more than a view. It's a living chronicle, written in light, linking us with an ancient and mysterious past. The universe invites us to listen with our instruments, to observe with our minds, and to imagine with our hearts all that has been, and all that is yet to come.